perfect square trinomials. So let's start by multiplying this out. M plus 5, the quantity squared, means we have to do m plus 5 times m plus 5. When we FOIL that, we get m squared, right, when we do first, and then outer, and then inner, and then last. When we simplify that, because we can combine like terms here, we get m squared plus 10m plus 25. So let's look at a little bit closer and see if we have any special patterns with this type of trinomial. Our first term, again, is a perfect square. Let's jump ahead a bit. Let's look at the last term. The last term is also a perfect square. The middle term is a little bit harder to pick up what the pattern is, but let's take a look at our first and last terms and see how that can determine the middle term. So I know that when I originally started in the parentheses, I had m plus 5, right? So m is the square root. If I do a square root of this term, I get m. If I do a square root of this term, I get 5. If I multiply these two together, I get 5m. And if I double it, I get that middle term. So we're looking at the square root of the first and last, multiply them, and double. So I take the square root of, and I'm just going to put square root of, actually, hold on. I'm going to try to write this as clearly as possible. So I have the square root of the first term times the square root of the last term, and then we double it. Right, so that's what the middle term is. It's the square root of the first term. It's the product of the square root of the first term and the square root of the last term, and then we double that. And then in terms of the signs of my trinomial here, they're all positive, but the first term will always be positive, and the last term will always be positive, because in this pattern, I'm doing the same number times itself, or added to itself, right? So I'm either going to have a positive 5 and a positive 5, or I'm going to have a negative 5 and a negative 5. But regardless of whatever this sign here in the middle is, when I multiply a positive times a positive, I get a positive. When I multiply a negative times a negative, I get a positive. So this last term will always be positive. And the first term will as well. All right, so let's look at these 4 trinomials on the bottom and see if we can determine which ones, if any, are perfect square trinomials. So we're going to look at the first term and the last term. Are they perfect squares? So in this example, yes, this is a perfect square. Yes, this is a perfect square. The next thing we look at is for that middle term. If I take the square root of the first term, I get 2x. If I take the square root of the last term, I get 5. If I multiply them together, I get 10x. And if I double it, I get 20x. That does not match my middle term, so this one is not a perfect square trinomial. Let's try the one right underneath it. First, we look at the first term. Is it a perfect square? Yes. Last term, is it a perfect square? Yes. Let's check the middle term. If I take the square root here, I get 10m. If I take the square root here, I get 2. Multiply them together, I get 20m. And then I double it, and I do get my middle term. So this one so far checks out. The last thing I need to check for are the signs. The first and the last must be positive. First one's positive, last one's positive. This one gets a big check because this one checks out. All right, let's look at the third one. We always check first and last terms. Is the first term a perfect square? Yes. Is the last term a perfect square? Yes. So now we have to check that middle term. Square root of the first term gives me 5a. Square root of the last term gives me 7. I multiply them and I get 35a. I double that and it does equal my middle term. So this one also checks out. Well, I forgot to check the signs, but everything here is positive, so I'm good. All right, last one. Check the first term. Yes, it's a perfect square. Check the last term. Yes, it's a perfect square. Let's check the middle term. Square root here, and I get 3b. Square root here, and I get 4. Multiply them together, and I get 12b. And when I look at my middle term, if I double that, I look at my middle term, it checks out. One more thing to check are my signs. The first one is positive. Ooh, but the last one is not. So even though it looked good up until the very end, this one is not a perfect square trinomial. All right, so that's how we can check. So now let's factor them. All right, we've got, we should always look for a GCF first. And it does appear that our numbers can be divided by a common factor. What number goes into 8, 40, and 50? Well, 2 definitely goes in because they're even. 4 only goes into the first 2. 5 only goes into the last 2. So it looks like 2 is going to be our GCF. So when I factor out a 2, oh wait, I can also look at my variable terms, right? What else? What can I factor out of x to the 5th, x to the 4th, and x to the 3rd? Well, they all at least have x to the 3rd. So I can also take out an x to the 3rd. When I do that, 8 divided by 2 will give me 4. And if I had an x to the 5th, and now I'm taking out 3 of them, that's going to leave me with x squared. In my next term, the 40 divided by 2 will give me 20. And x to the 4th, if I take out 3 of them, that's going to leave me with just an x. And then in the last term, 50 divided by 2 is 25. And x to the 3rd, if I'm taking out x to the 3rd, then that's it. Now I'm looking to see if this is a perfect square trinomial. First term is a perfect square, and it's positive. Last term is a perfect square, and it's positive. When I take the square root of this term, I get 2x. Square root of this one, I get 5. 2x times 5 is 10x. And I double that to get 20. So it is a perfect square trinomial. And the way that I factor it is actually a lot like my checking. I take the square root of the first term, and that will go here and here. I take the square root of the last term, and that will go here and here. And then I take the sign of my middle term, and it's repeated in both. Now we can FOIL this back out just to make sure. If I do 2x times 2x, I get 4x squared. If I do my outer, I get negative 10x. If I do my inner, I also get negative 10x. So those will combine to give me negative 20x. And then negative 5 times negative 5 is positive 25. So it checks out. All right, let's try this next one. Here, I don't have any GCF that I can take out because my first term has no number, has no coefficient. So there's not something that I can divide all the numerical parts by. And then my last term has no variable part. So there's nothing that I can take out in terms of the variable. So this is already factored as far as taking out the GCF. Now I'm going to factor it into two binomials. So let's look at our pattern. Let's see if we have one. b to the 12th is a perfect square and it's positive. 144 is a perfect square and it's positive. If I take the square root of b to the 12th, I get b to the 6th. If I take the square root of 144, I get 12. And if I multiply these together, that gives me 12b to the 6th. If I double it, then I do get 24b to the 6th. So it checks out. So now I'm going to use these square roots to factor it. So I have my two sets of parentheses. The square root of my first term, like we already said, was b to the 6th. Square root of my last term is 12. And my middle term has a sign that's positive. So that means that these both get plus signs.